Hello and welcome to Diana's Makerspace. Today I'm at Barnes & Noble in Racine, and I'm doing a study basically on discussing small language model AI. Traditionally AI uses large language models, but I prefer to use small language models. The reason why is, let me show you an example. Now in the example that we're looking at, this is my small language model that I developed last night. I used this actually to figure out a rating system on how to rate football players, basically for defensive positions, because normally there's a quarterback rating for positions, but I also expanded this to rate offensive players as tackles, guards, punt returners. But on defense I started with defensive backs, linebackers, because many times the coaches want to know what is the rating for different players. So the reason I call it small language model, because instead of using a massive AI that's available where you have many hours of computation time, GPU time, this can be done actually with knowledge of basically tokenization, cognization, paper and pen, and a TI-59 programmable calculator. Yes, the TI-59 programmable calculator from the 70s. The basic model uses what every other language model uses. You have a rating, and it's a summation of what the token value is with the adjusted weight. Now the thing is, what happens though, where you can save time is if you have the knowledge of cognitive science, basically applied mathematics, and intuition, you can figure this out faster than you could using a large language model. And this other part with the tokenization, if you have knowledge of the sport that you're looking at and how it's played and what's important in play, you can figure out what the tokens are. Now using this method, this is how I developed ITS in 1989, except at that time I used an Osborne 1 with the code written in Module 2. But actually I could write this program, which I'll do is I'll write this in Lazarus because I prefer Lazarus over C#. And the values are value of the token. So like most language models, you'll have a token. Like for example, if you were to have a query like this is a test is a valid sentence. Okay, so you have a token. This would be a 1, this is a 2, is a 3, test is a 4, is a 1, is a 3, valid is a 5, sentence is a 6. So what happens, you make a token string of 1, 2, 3, 4, 1, 3, 5, 6. So that's how a large language model uses it. It takes a sentence, it breaks it down into tokens from a data dictionary. And then from these tokens, it puts these tokens into a form of a neural network. And it gives some sort of result like that. So you have it going into a neural network. Now the thing is, when you think of the neural network, many of these neural networks are loops. So basically you have one neural network, another neural network, so it goes like this, like this, like this, like that, like this, like this. So you have clusters, you have a bunch of clusters, and this leads into a very exponential time process. However, if you know what you're doing, you can do what I did last night, basically using a TI, using my knowledge of sports, and also knowledge of cognitive science. And you can make a neural network which is a non-exponential time, because basically you're only using this part right here, and you're not using all of this, so you're saving a lot of CPU time. Well, the thing is, I implemented this on a TI-59 programmable calculator. There's so many steps. I called the local football team to ask them to show them my initial results. I'm waiting for the response. But the point is, Kanecki small language model is, I think, sometimes more effective than large language model. And I'm planning to put this out on GitHub or SourceForge soon. But this is the first example of it using a football rating system for defensive football players. And this shows where basically, if you know how to do something, you don't have to use a large language model. You don't have to be a slave to AI. You can do other stuff with it. But the thing is, I'm not saying go away from AI. I'm saying don't use AI as a crutch. Make sure you know exactly how to do things yourself, because the problem that exists in AI is I hear a lot of people talking, well, I'm a good programmer. Only the junior programmers will be affected. They want AI will replace junior level programmers and entry level programmers. Well, the problem is, in any organization, the people who are the entry level and junior level people are your future. And if you eliminate the beginning of your future, you eliminate your future. So basically, we have to think on how we use AI. So I don't agree with the thing about replacing people with AI. I believe in using AI to augment work, but not to replace people at work.